All right, this is section 2.6, and it's called algebraic proofs. We're going to start off with the properties of real numbers. Then these are going to be our reasons why we're allowed to do the various steps in the algebraic proofs. So we have the addition property of equality, and I'm going to give you examples because you'll have the chart. So if I have a minus 3 equals 7, I can add 3 to both sides of the equation, and I get a equals 10, and they're still equal, okay? So we have the subtraction property of equality. And so our example would be if we had a plus 3 equals 7, we could subtract 3 from both sides, and you would get a equals 4. Okay, then we have the multiplication property of equality. Okay, so my example here, if I had a divided by 2 equals 7, I could multiply both sides of this equation and get a equals 14. And we're still going to have an equality. Division property of equality. So an example of that would be if I had 5 times a equals 15. If I divided both sides by 5, I would get a equals 3. Okay, so then we have our reflexive property. So this is reflexive with an X, not reflective, even though it seems like it might be reflective, CT, because it's when you have the same thing on both sides of your equation. And this is also a property of equality, but it's also a property of congruence. So an example would be like 4 equals 4. Or angle A is congruent to angle A. Reflexive property. We will use that a lot later, not so much now, but the symmetric property of equality. I'm going to write equality and congruence. Okay? Remember, that's the symbol for congruence. So if A equals 5, then 5 equals A. Or segment AB is congruent to segment CD, then CD is congruent to AB segment. All right, the transitive property of equality and congruence. If A is equal to 10/5 and 10/5 is equal to 2, then A equals 2. Or we could say if angle C is congruent to angle D and angle D is congruent to angle E, then angle C is congruent to angle E. So notice that this middle part right here, these are the same. It's like the connector on a train. So that's why I think of transitive and I think of train. Anyway, substitution property of equality and congruence. So here, this is when you can replace something into another algebraic expression. or equation as long as it's equal. So if A equals 5 and 6A plus 2, we're not even going to put an equals, we can now write 6 times 5 plus 2. We can substitute it in. This one, the distributive property of equality only, not congruence, because we do this with numbers. This is when you have a number out front, like 3 times something in parentheses, that we distribute the 3 times the 2x and the 3 times the 7. So we're going to prove that if -5 times x plus 4 equals 70, then x equals -18. All right, so what we're going to do, we're not just going to do the math. We're going to justify each step, but we're also learning how to set up a proof to make a 2-column proof. All right, so the first thing we would have is we would have a given information. We're going to have given information. And then we're going to be told what to prove, okay? Then we're going to make 2 columns. One of them is going to be called the statements column, and one of them is going to be called the reasons. So this is how we will set up our proofs. All right, so the given information is your if information, the stuff in the if part of the thing. So it's the given is this, if this is true. So I'm going to write -5 x plus 4 equals 7. And then what I want to prove, it's going to be the then stuff. Because we're writing a conditional statement. If this, then that. That's conditional statement. We're going to talk a lot more about conditional statements, but so we write down what we want to prove. X equals -18. All right, so the first statement that we always write is what we were given. And our first reason is going to be, how do we know this? How were you able to get this information? Well, it was given, so that's our reason. Okay, so our next step is, what would we do next for this equation to solve it algebraically? Use the distributive property. So let's do it. -5 times x is -5x minus 20 equals 7. Okay, so my reason is, how did I get from here to here? What did I do to this to get this? I used the distributive property. And so that's my reason. This distributive property of equality. Okay, so the next step in figuring out what I can do is I would isolate my variable and get rid of anything that's not in that same term. So we're going to say -5x equals 27. You guys, I made a mistake at the beginning. This is supposed to be a 70, not a 7 up here at the top. So make all of those 70s. This is supposed to be a 70. 70, 70. All right, so that's not right then. We did not get 27 from when we added 20 to our 70. What do we get? 90. How did we do that? Well, we added 20 to both sides of the equation. We added it to both sides and still equal. We're allowed to do that because the addition property of equality. Now, I'm going to do the next step. I get x equals negative 18. How did I get that out of the negative 5x minus 90? Well, right next to where I find my result, the way I got that answer, that was the division property of equality. Okay. Oh, and notice that this right here is the same as what I'm trying to prove, and now I'm finished. What property justifies the statement? So the first one, if the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 3, then the measure of angle 1 equals the measure of angle 3. Okay, so that would be the transitive property. All right, let's try another one. XY, the length of segment XY equals the length of segment XY. The reflexive property. Get what I'm doing here? Do another one. 3. What property justifies 5 equals X, then X equals 5? The symmetric property of equality. All right, so there's those. And then you're going to have a proof like we did over here. You'll have a proof to try yourself. So I want you to set it up the same way. Remember the setup for the proof is you're going to have your if-then statement. Okay, so you get your given information. And then what you want to prove, you write down that, it's like a heading for the proof. You write your 2 columns, you have your statements, and your reasons. This is where the first one, you always write what you're given, and the first reason is always given. Okay? And then you just do the next step, and then you give its justification, and it can be various lengths long.